Hello and welcome to another section in further math. In this section we'll be looking at a change of base of logarithmic functions, but before that let us review our previous lesson. Okay, welcome back. Now today we'll be talking about change of base. Now when you talk about change of base, we're talking about changing the base of a logarithmic function. For example, if you have log b a, in change of base this log is equal to, you still have log b c all over log a c. Now in changing the base to c, you've changed it this one. Now this logarithm here is equal to the logarithm here. Now in order to clarify it, let us prove that log b a times log a b is equal to 1, and this, if it's equal to 1, then we've proved that this rule is correct. Now remember I said log ba is equal to this, so we would have log ba being equal to log bc all over log ac, and log ab, the logarithm of a and b, is equal to log ac all over log bc. Change of base, this is the same thing. The noun, let's multiply here and here. We now have log bc over log ac times log ac over the logarithm of bc. Now with this we are moving further into solving log bc log ac log bc log ac all over log ac log bc. Now with this, you know, you have log bc cancels log bc, and log ac goes with log ac. This is 1, this is 1, this is 1, this is 1. So we now have 1 times 1 over 1 times 1. 1 times 1 is 1 over 1. So 1 divided by 1 is 1. So with this, we have been able to prove that log ba times this equals to this, which shows that the logarithm of b over a is equal to log bc all over log ac. I would like us to proceed further in logarithm, but let's first of all express numbers into standard forms. Standard forms. Example: express 7853 into standard form. Now what you need to do is, if you start adding a point, you start adding a 0. Now for example, if you put a point here, you now have 10. You shift the point here, you have 100. You place a point here, you have 1000. So if you're working with one decimal place, your answer becomes 7.853 times 1000, and 1000 is the same thing as 10 raised to the power 3. So it's 7.853 times 10 raised to the power 3. That's the value. We've converted this into standard form. Now this is more example. We can I can as well give you 0.387 and say convert to standard form. Now this is where the 0 is in front of a 3. If you're taking the 0 this way, you'll be adding 10 raised to power minus 1. If you take it here, it becomes 10 raised to the power minus 2. If you're bringing it this direction, like this, it's minus. But if you're taking it this way, it's plus. So this 0.387 is the same thing as 3.87 times 10 raised to the power minus 1. It's a minus sign because this point was brought to this direction. So you can actually apply it 0.00104. Now let's count how many times we are taking the 1. Now this point is here. We are taking to this side, so it's minus. If you bring it here, we have 10 raised to the power minus 1. Take it here, 10 raised to the power minus 2. Take it here, 10 raised to the power minus 3. So it becomes 1.04 times 10 raised to the power minus 3. This is just how to convert numbers into standard forms. I would like to say a very big thank you for joining us in this lesson. But in order to refresh your memory on what we've just discussed, please take the test that will appear on your screen shortly. Do well to use the lesson notes on the portal for better information on the topic we've discussed.